shall we move on to Rocco, and then obviously we can come back to more questions in the end?
Yeah, exactly. Because hopefully, maybe I can, maybe my presentation will focus maybe on some additional things, and we can maybe afterwards have a little bit of a discussion. I think if I put it, yes. Can you see my screen now?
Yep.
Okay. So basically, I want to talk about more or less the same problem. Of course, we have maybe there in some parts also a little bit some different solutions, and yes. So let's see how we addressed this problem. So Lucas also started with a short overview over the company. So I also want to maybe take a minute. So I'm part of MinRes. MinRes is a privately held company based in Munich and in Germany, and we are focusing on different topics, but mainly services around providing support for productivity, IPs. We also started to go a little bit on selected IPs into RTL implementations, specifically around RISC-V, and we also have some solutions for hybrid simulations between RTL and virtual prototypes. So my view on this on the traces is first of all, if you throw out the word traces, I think most people, the good thing is most people have a pretty good understanding, and they are already used very widely in the industry. Also, they are sometimes even used for documentation. So when you want to show like what kind of performance you have, sometimes people use trace data. So that's great. But when you look a little bit more closely, it's actually kind of tricky. Everybody understands a little bit some different things about around what they want to see or what they have with traces. The most common thing is, of course, coming from more in hardware design view. You have kind of these VCD-like traces. All HDL simulators support them very well. This is pretty well understood, and we do believe that it does make sense to build up on that, because it is so widely used already in the industry. I mean, the fact that there is a default implementation of the VCD tracing in the SystemC reference kernel, I mean, tells you how important it is. And as far as I can tell, this generating VCDs is very widely used in the industry. Now, so as I said, for signal type information, the tracing is actually relatively straightforward. VCD it might not be the best choice in the world, and we come a little bit later to some examples or some information what we did there. But it is kind of a default choice, so we do believe that you do need to at least support information that is dumped in VCD. There is then, of course, more interesting or more complex data typically, and for us, it is the first thing is always TLM transactions. Tracing these TLM transactions with some kind of an VCD interpretation is pretty cumbersome. Transactions have different time points, a starting point, an end point, and if you have actually more complex transactions that follow the more realistic AMBA-like transaction standards. You have even within a transaction different timing points, talking about bursts, talking about snooping transactions, all these things. So it can be that can be very tricky. There is people trying to do that in VCD, but we believe that is not really very efficient. So why do we, well, some people even question why do we need this whole notion of transaction tracing? We do feel that a common, well-formed definition of transactions would be good for the industry. I think just like what Lucas said, the problem is often that different people, different IPs, different tools have different implementations, and that can really be tricky when you want to integrate different models. So basically, what we also feel there, we want kind of I would say the VCD equivalent for transaction tracing. So what did we do as Minres? We have a productivity library. It's called SCC. And it has a number of features in there. It's basically a library on top of SystemC. What we found, first of all, is that there would be a number of possibilities to improve the signal type tracing. So what we did in the SCC, we are providing a module called a tracer, which automatically collects signals, ports, variables, CCI parameters. I think I should mention that here as well, since Jakob brought that up. And this tracer will basically collect this information automatically and put it, as long as you have opened a database in the beginning of your simulation, or before you begin your simulation, it dumps it in that database. Now, on the database, we see that the default implementation in SystemC is, well, it works, but it doesn't work very efficiently. So we have done a number of things to actually do our own implementations of VCD, and also we extended it to an FST format. There was a bit, we debated what would be a realistic format that we can support. There's, of course, a number of compressed formats out in the industry, but we really wanted to have a format that is open source based, and there FST was really the default choice for us. FST comes from the GDK Wave environment. There's also converters from VCD to FST, but we basically have a tracer implementation that would give you directly an FST implementation. Of course, if you want to go to a viewer that doesn't read FST, you would use these converters to VCD. And I have later some examples for what we saw as results of these additional implementations. Yes, so the one of the bigger differences that really changed the performance was, for instance, that we changed the VCD implementation from kind of a poll modus where you check every cycle if a signal has changed, really into a push mode, and that really improves significantly the performance of the VCD tracing. So a little bit more interesting, or still more tricky, is the implementation of transaction recording. And here's basically where we feel also there should be a debate, if that could be more standardized. We did start with an implementation based on the SCV library, which had actually a definition of transaction streams. However, we do have at least our impression is that SCV is not any longer used very widely. And so we didn't really want to rely too much on that on that basis. We would like to see that something that is really reliable would be out there, but yes, we did then an alternative implementation, what we call lightweight transaction recording, LWTR, and implemented that or added that also into the SystemC library. So what happens then is if you use this tracer, you can also trace, you not only trace signal type information, but also TLM type information, and even with some extensions. I think there's another slide on that. There is also, in terms of the back end, there's two different implementations where we can generate kind of a text format, which can be sometimes useful if you want to basically just read or post-process this file. We also have a compressed format that we call FTR, which is significantly smaller. It's also faster to write out. But then, of course, you need, there's basically an API to pull information from that FTR. We do provide some example APIs for C++ and Python. But of course, it's still, you need to use that API. We have viewers. I think there's also later a slide on that allow you to visualize also this transaction-based format. Yes, so there is basically in SystemC there is a transaction recorder module, or actually modules that which you could put in to your system if you use TLM traces with certain extensions. The extensions is, to me, it's always the most tricky part about this whole system, because pure TLM transactions, from my point of view, they do work well in pure virtual prototypes, but as soon as you bring in some more timing information to get some more of the architectural details, you really need to expand the plain TLM format with some extensions. And so as long as you have these recorders enabled, these recorders can also be in part of some socket implementations, but we did explicitly want also the option to basically say, well, people can use their own ports, and then maybe just fill in recorders at certain places where they feel they are strategically important. So you could choose whether you want them to be enabled everywhere, or whether you want them just in some parts. So here's just some example how this tracer module would look like, where you instantiate here this class, a configurable tracer. And I didn't talk about that too much, but there is basically a way to enable and disable also either all or based on hierarchies, the elements in certain module levels. And this format here with this configurer, this is actually something that basically reads either a JSON or a YAML file, and it fills in a CCI-based database to enable, disable different components for tracing. Yes. Some more things that we found quite useful is, for instance, that you enable maybe your tracing, your VCD tracing, or your transaction tracing only during certain times in the simulation. We find it often useful that basically that before 2 microseconds nothing relevant happens, and in order to reduce the file size, you just say trace everything, but trace it only after 2 microseconds. And we use there basically you can register a callback function. We have it here just implemented as a lambda that would basically return true or false for certain time periods. As Lucas also said, of course, the database collecting the information from the database is, or let's say, what a user is really interested at the end is what he can do with this data. Trace visualization is there always the first thing that people ask for, but I would say, just like also what Lucas mentioned, the implementation of the visualization tool is probably different from agreeing on the format. The visualization tool, that I think there will be different implementations from different companies, and those will be probably not all of them will be open source, but it would be really better if we could agree on a standard database that these visualization tools are using. So here we have also, there's so the first visualization tool that was shown was SC Viewer. Here there's another visualization tool which is called Impulse by a company called 2M. Yeah, and for the VCD or FST type formats, there, of course, we typically just use GTK Wave, but again, GTK Wave, there you only have the option to visualize the signal type traces. We have even experimented with basically converting the formats into other proprietary trace formats like FSDB. This is also possible. We do feel, that there should be probably different backends, but again, it would be probably more a question of agreeing on a common format to trace everything, and then the visualization tools, you hope that somebody is linking to this database. But we can even do some things here to shortcut, to kind of enable certain flows on demand. But of course, as I said, we want to avoid normally to get too much dragged into specific commercial tool implementations. Of course, what we also see besides just visualization, the other thing that you want to do is you want to often post-process the data to extract your own kind of information, and that is typically quite difficult to predict. I think everybody there wants to see other type of informations. And we do have some example scripts that allow you to extract common information, kind of like, for instance, from these transaction traces. We can generate what we call transaction journals, performance summary, where we summarize bandwidth, latency values, but it is really here, the interesting part actually starts here, because really what you want to enable is to have customers or maybe even tools to generate really their information from these traces. And just some an example for what we call dashboarding, where you put together the visualization, but also maybe graphically visualize some of this information that has now been generated from all these different traces. And yes, I think, now, of course, there's two more slides that actually summarize some of the results that we got from our different implementations. So what we compare here in these different columns is the default VCD implementation in the Accellera kernel. Then we have done a number of our own implementation changes. One, for instance, where we try to follow through the tree that signals, for instance, like the clock, are not traced multiple times, because typically clocks traverse multiple hierarchies, and then you get just a lot of information that is actually just duplication. So we automatically remove that. Then this VCD push implementation, and an FST-based implementation. And here we compare basically their impact on the simulation time. So how much overhead you get during the simulation time when enabling these different methods, and the file size. And also here you can of course always with VCD also do simple LC4 compression. But we found actually that really the best results is then going directly to an FST-based file, which is by default a compressed format. And for transaction traces, we have shown here something similar. So this TX, what we call here TX log, is kind of a text output. So this is this text-based tracing. Then there is an FTR based implementation. This is what we call lightweight tracing, and on top of this lightweight tracing, you can even do some additional compression, which did reduce the file size a little bit, with relatively little overhead if you compare the 76% versus 73% on the overall runtime. And what we do find here then also important is that, especially on these transaction traces, as they grow larger, it is also more and more difficult to actually post-process them. So that's why we compare here also the time that it took basically to post-process these files again later on. And also here you can see basically that text-based formats then really provide quite an overhead when you want to post-process them versus these other more database-like formats. Okay, yes, and I think now hopefully we do have still some time for some discussions, but for us really the really important thing would be to align somehow around, for us specifically around the topic of transaction recording. These transactions, it doesn't have to be a TLM2 based transaction, by the way. It can be also transactions where you just trace some events, like in your simulation, where certain important things happen, a cache miss or whatever, things that are basically where you have maybe some more complex information that you want to trace that doesn't really lend itself to a VCD type tracing. And we would like to see also actually a better VCD implementation as part of the SystemC standard itself. I mean, we implemented our implementation, but we do feel VCD is very important for us in basically in our everyday life. So if it would be part of the standard directly, that from our point of view would be better. And of course, with RTL simulators, or I guess with any simulator, it would be great if we could also align with these tools. I do want to point out again, for us, it is very important that we do have implementations that are open source based, at least for the generation of the data. But of course, it would be best if all the tools basically then also agree on that common database. Well, it's a wish list. Yeah. I think that's it from me.